Welcome you all to the next lecture session on areas related to a circle. So in this lecture session we will go through the areas related to a sector and the segment of a circle. Now we need to understand what a segment is and what a sector is and how we can calculate the area of a sector and the segment of a circle. So here I have considered a circle with center O. I have drawn two lines OA and OB. So OA is of course the radius of the circle and OB also is the radius of the circle. So now there is a region which is enclosed by the two radii OA and OB and an arc AB, right? So therefore if you have a portion of a circle which is enclosed by two radii and an arc, so that region is referred to as a sector. So this region is referred to as a sector. And now we define what is a major sector and what is a minor sector. Now this region is of course much smaller when compared to this entire region. Now this region is much smaller compared to this entire region. So this region shaded in black is referred to as a minor sector and this is referred to as a major sector. Now the entire angle is of course 360 degrees. So let us try to define the angle made by the major sector. So the total angle of course is 360 degrees. So now when we want to find the angle of the major sector, so it has to be 360 minus the angle AOB. So angle of the major sector is 360 degrees minus AOB, angle AOB. Now if I want to find the area of this minor sector, now what is the area of the entire circle? The area of the entire circle of course is pi r square. Let us assume that the angle AOB is theta, right? So now if I want to find the area of this sector here, we find that that would be this area making an angle theta at AOB. Now let us assume that the angle AOB is theta. Now if I want to find the area of this minor sector, first let us try to find the area made by 1 degree. So now if I have a sector such that the angle is 1 degree, so area of a sector having 1 degree, right? So we know that the entire angle is 360 degrees. So therefore the area of a sector for 1 degree is definitely 1 by 360 into pi r square, right? So I need to divide the entire area by 360 to get the area of the sector having an angle 1 degree. So now the question is, if I want to find the area of a sector having theta degrees, I just need to multiply this by theta. So it's going to be theta by 360 into pi r square. Okay, so if we need to find the area of a sector having theta degrees, it is going to be theta by 360 into the area of the entire circle. So this is as far as the sector is concerned. So now let's talk about a segment. If I have a circle and therefore we have a chord which intersects the circle at AB, right? So you have a chord AB and we have an arc. So let this be arc APB. So this is referred to as a minor segment and this is referred to as a major segment. Now the question is, how do we find the length of APB, arc APB? the circle having center O, let us join OA and OB. So the angle is theta here, right? The circumference of the entire circle is 2 pi r. So circumference of the entire circle is 2 pi r. Okay, so if I have a small region such that the angle is 1 degree and I want to find the length of that segment, so that would be, if this is a 1 degree, then the total angle is 360 degrees, right? So the length of the circumference made by an angle of 1 degree is nothing but 2 pi r divided by 360. Okay, but now here we have a minor segment which makes an angle theta. So what is the length? So the length of the minor segment making an angle theta would be theta by 360 into 2 pi r. Right? So this is the length of the arc when the segment makes an angle 1 degree. Right? So it's going to be 2 pi r by 360. So instead of 1 degree, I have the segment making an angle theta. So therefore it's going to be theta by 360 into 2 pi r. Okay? So this is how we can find the length of the minor segment. So theta by 360 into 2 pi r gives us the length of the minor segment. So now we have a very important question, whether we can find the area of APB. Is it possible for us to find the area? So we can definitely find the area of APB, where considering this AOB sector, so we know that the area of sector AOB is nothing but theta by 360 into pi r square, right? So this is the entire area. So if I want to find the area of this minor segment alone, which is APB, the shaded portion, so then the area of the sector or the segment, the area of the segment APB is nothing but the entire area of this sector, which is given by area AOBP minus the area of this triangle. So here this forms a triangle AOB minus area of triangle AOB. Right? So this is given by theta by 360 into pi r square minus area of the triangle AOB. So based on the nature of the triangle, we can find the area and then we can subtract it and then we'll get this area of the segment APB. So with these fundamentals, we'll solve all the problems given the second exercise of this unit. The second exercise, first problem, find the area of the sector of the triangle whose radius is 6 centimeters and angle theta is 60. Right? So we have a circle here and the radius is 6 and the angle is 60. Right? So we know the formula. So the area is given by theta, which is 60 divided by 360 into pi r square, which is 6 square. So this gives us a value of 132 by 7 centimeters square, where pi is 22 by 7. So next, find the area of the quadrant of the circle if 2 pi r equals 22 centimeters. So we need to find the area of the quadrant of a circle. Quadrant means the angle here is 90 degrees. So we have a sector making an angle of 90 degrees and 2 pi r is 22. So therefore we can find the value of r. R is 22 by 2 pi, which is 11 by 22 into 7, which gives us 77 by 22, or 7 by 2 centimeters. So the radius of the circle is 7 by 2 centimeters. We need to find the area. So therefore the area is, the angle is 90. So 90 by 360 into pi r square. Pi is 22 by 7 into r square, 7 by 2 the whole square. So this is of course 1 by 2, right? So finally we get the area as 9.6 centimeter square. The third problem is a very interesting problem. The length of the minute hand of a clock is 14 centimeters. So there's a clock here, the minute hand. So the length is 14 centimeters. 14 centimeters. Find the area swept by the minute hand in 5 minutes. So in 5 minutes, what is the area swept by the minute hand? Right? So if the entire clock, the circle, a clock is a circle, is divided into segments of 5 minutes, right? So then we get 12 regions, right? So the angle made by the sweep when it traverses or covers a time period of 5 minutes would be 360 by 12. So that gives us 30 degrees. So this angle here would be 30 degrees. So you have a clock, say if this is 5 minutes, then it is 10 minutes. So the angle would be 30 degrees, right? So we have the angle as 30 degrees. So now we need to find the area, which is very simple. So again, area is 30 by 360 into pi, which is 22 by 7, into r square, which is 14 into 40, right? So we get the area as, if we calculate, we get it as 154 by 3 centimeter square. Problem 4. A chord of a circle having a radius r equals 10 centimeters subtends a right angle. It subtends a right angle at the center. Find the area of 1, the minor segment, and 2, the major sector. So we need to find two things here. So what has been given? There is a circle and the radius of the circle is 10. It is 10 centimeters. Now there is a chord. So let's assume that the chord is AB, right? It subtends at the center right angle in the sense that the angle made by AOB is 90 degrees, right? So it has been given that a chord of a circle subtends a right angle at the center. So this angle is 90 degrees. So we are given that AOB is 90 degrees. Okay. So now we need to find the area of the minor segment and the area of the major sector. So the area of the major sector is this. So if I shade this entire area, so this is the area of the major sector. So how do we find the area of the major sector, which is much easier? We'll finish that first. It is the area of the entire circle minus the area of the minor sector, which is AOB. AOBP, right? So area of the major sector, area is the area of the circle, which is pi into r square, minus the area of this minor sector, which is 90 by 360 into pi r square. So here we get 314 minus, so this value is 78.5, so which gives us 235.5 centimeters square. Okay, so this is the area of the major sector. So now we need to find the area of the minor segment. So let us shade this portion. So if I shade this portion here, this forms the minor segment, so we need to find this area is what has to be found. So the area of this is the area of the minor sector minus area of the triangle AOB. So area of minor segment is nothing but the area of the minor sector. What is the area of the minor sector? Which is 78.5, which we have already calculated, minus the area of the triangle AOB. So this is a right angle triangle. So we have nothing but half into the height and its base, which is 10 into 10. So we get 50. So we have 78.5 minus 50, which gives us 28.5 centimeters square. Right? So this is 10. So one of them is the base and the height. Okay. So therefore, it is half into 10 into 10. So if you have a right angle triangle, angle is 90 degrees, the base is 10, right? The base is 10 and the angle is 90 here, the height is also 10. So it is half into base, which is 10, into height, which is 10. So we get 50. So 78.5 minus 50 gives us 28.5 centimeters square. So this is the area of this segment APB, which is shown in shaded blue. Problem 5. In a circle of radius 21 centimeters, an arc subtends an angle of 60 degrees at the center. So we need to find the length of the arc, 1, 2, area of the sector formed by the arc, and 3, the area of the segment formed by the corresponding arc. Right? So let us draw the diagram. So we have a circle there. Let the center be O, and the radius is of course 21 centimeters, and you have a chord here. Let the 2 points be AB. Let me call this as P, and the angle made is 60 degrees. So we need to find the length of the arc. So the first thing is the length of the arc APB, which is 60 by 360 into the entire circumference of the circle, which is 2 into pi into r. So we get it as 22 centimeters. So r is 21, pi is 22 by 7. So we get it as 22 centimeters. Next, 2, we need to find the area of the sector formed by the arc. So we need to find this area. So area of the sector AOB is 60 by 360 into pi into 21 square, which is pi r square. So this is of course 1 by 6. So we get the value as 231 centimeters square. 3, we need to find the area. So we need to find the area of APB. If I join A and B, I need to find the area of this shaded region. So the area of APB is the area of the entire sector, which is AOB, minus area of the triangle AOB. Right? So we have already found the area of the sector, which is 231, and we need to find the area of the triangle. So when we observe, this is 21 centimeters, so this is also 21 centimeters. So this is 60, so definitely these two angles will also be 60. So we realize that this is an equilateral triangle. So the area of an equilateral triangle is root 3 by 4 into a square, which happens to be the side of the triangle. So therefore area of this is 231 minus root 3 by 4 into a square, the side. So the side of the triangle is of course 21, so 21 square. So this gives us 231 minus 441 into root 3 by 4 centimeter square. So this is the area of the shaded region. Problem 6. A chord of a circle having a radius r equal to 15 centimeters subtends an angle 60 degrees at the center. Find the areas corresponding to the minor and major segments. The problem almost remains the same, a similar problem I should say. So we have O as the center. So there is a chord. So let the chord be AB. Let's join these two. So therefore the radius is 15 centimeters. The angle is 60. So we need to find the area of the minor segment. Area of the minor segment is this. So we need to calculate it on similar lines. So the area of the minor segment, so area of the minor segment APB is area of the sector, we should say the minor sector AOB minus area of triangle AOB. So again this is an equilateral triangle, so the angles are 60. So area of the minor sector is, the angle is of course 60 by 360 into pi r, r is 15 square, minus area of this equilateral triangle which is root 3 by 4 into 15 square. So we get the value as, so this is, if we calculate, 117.857 minus 95.625, which is equal to 20.43 centimeters square. So this is the area of this shaded region. So now we need to find the area of the major segment. What is the area of the major segment? The entire thing which is shown in blue is the area of the major segment. So if I calculate the area of the circle and subtract the area of the minor segment, I get the area of the major segment. So area of major segment is the area of the circle, which is pi r square, pi into 15 square, minus area of the minor segment, which is 20.43. So if we do the calculations, we get 686.06 centimeter square. Problem 7. Chord of a circle having a radius of 12 centimeters subtends an angle of 120 degrees at the center. Find the area of the corresponding segment of the circle. So let us consider a circle with center O, and we have a chord. So let the chord be AB, and this chord subtends an angle of 120 degrees at the center. So this angle is 120 degrees. So we need to find the area of the corresponding segment of the circle. So in general we need to find the area of the segment here. So if I call this point as P, let us find the area of APB, and we also need to find the area of OAB also. So correspondingly, to find this area, I need to find this area. Now we know that the area of this entire sector is, so we have the area of sector, the minor sector, is the angle theta, which is 120 divided by 360 into pi r square. So this is 1 by 3, r is 12, so we get a value of 150.72 centimeters square. So this is this entire area of the sector. Now to find the area of this APB, I need to find the area of the triangle AOB, right? So now let me draw a line which is absolutely perpendicular to AB, dividing AB into two halves. So therefore, this OA is 12 and this also is 12. And since we have the line which divides the angle, so this is 60 degrees and this also is 60 degrees. So now let us consider triangle AOB, right? So considering triangle AOB, now the triangle AOD, when we consider triangle AOD, angle AOD is definitely 60 degrees, okay? And now we also know that OD is perpendicular to AB, right? So we have chosen the line OD to be perpendicular to line AB. So therefore, this angle is 90 and this angle is 90 degrees. So this is 90, this is 60. The sum of all the three angles of a triangle is 180 degrees. So this angle is of course 30 degrees. Right? So now, finding cos 30. So what is cos 30? It is the adjacent side, which is AD, divided by the hypotenuse AO. So AD by this AO is 12. Okay, so I need to find AD here. So AD is cos 30. Cos 30 is root 3 by 2. So we have root 3 by 2 into 12, which gives us 6 root 3 centimeters. So AD is 6 root 3 centimeters. And similarly, what is sine 30? Sine 30 is the opposite side, which is OD by AO. So therefore, we have OD divided by 12, which is sine 30. Sine 30 is 1 by 2. So 1 by 2 into 12 is OD. So which is equal to 6 centimeters. So here the distance OD is 6 centimeters. This is 6 root 3. And we have chosen the line OD which bisects the line AB. So AD is equal to DB. So AD is equal to DB. So the entire length AB is 2 into 6 root 3, which is 12 root 3. Right? So now we can find the area of the triangle. The area of the triangle AOB. So area of triangle AOB is half into the base. Base is AB, which is 12 root 3 into height, which is 6, which is OD, right? Into 6. So which is 36 into root 3 centimeters. Centimeters square. So this is the area here. So we need to find the area of APB. So therefore, area of the segment APB is the entire area of the sector, which is 150.72 minus 36 root 3, which gives us 88.44 centimeters square. Okay, so we need to find the area of this triangle, and then we need to subtract the area of this triangle OAB from the area of the sector to get the area of the segment AB. So next, problem 8 is a very interesting problem. So a horse is tied to a peg where we have a square field having a side of 15 centimeters. So there is a square field, right? So here the horse is tied. You have a horse here, and the length of the rope is 5 meters, and this is 15 meters. The length of the field is 15 meters, which is square. So now the horse can move in this direction alone, and it can only graze in this region, right? So this can be considered as a circle having a radius of 5 meters, and this angle of course is 90 degrees. So we need to find the area where the horse can graze. So we need to find the area of the sector where the angle is 90 degrees. So area where the horse can graze is 90 by 360 into pi r square. R is 5 meters. So 5 square is 25. So we get 25 by 4 pi meter square. So this is the area which the horse can graze. So this is equal to 19.625 meters square. Now if the length of the rope is increased to 10, so the length of the rope is made 10, what is the increase in the area is what we need to know. So let us find the area. So this is 5 meters. So area if the length of the rope is 10 meters is again 90 by 360 into pi 10 square. So we have the area is 78.57 meters square. So what is the increase in area? So the increase in area is the area where the rope length is 10 meters minus the area where the rope length is 5 meters, which is 78.57 minus 19.625. So we get an area of 58.875 meters square. So this is the increase in area when the rope length is increased from 5 meters to 10 meters. A brooch is made of silver wire such that the diameter is 35 millimeters. So the diameter is 35 millimeter. So this is the diameter. And a wire is also used in making 5 diameters which divide the circle into 10 equal sectors. So this diameter is 35. So apart from that, we also have 5 diameters to divide the entire circle. That these are the 10 equal sectors. So we need to find the total length of the wire. So let us first consider the length of the silver wire to form the entire circumference. So the circumference is given by 2 pi r, which is d. The diameter is 35 into pi millimeter. So the silver required to form this is 35 pi millimeter. Next, the length of each diameter is 35. So there are 5 diameters. So we have 35 into 5. So that gives us 175. So this is 35 into 22 by 7. So which is 5. So we get 110 millimeter. And the length of silver required to form these 5 diameters is 175 millimeter. So the total length is 175 plus 110 millimeter, which is 285 millimeters. So the total length of silver wire required is 285 millimeters. Now what is the area of each sector? So we want to know the area of each sector. It is assumed that all these areas are of equal. The areas of each sector is equal. So there are 10 sectors. So the area of the entire circle is pi r square. So pi into r, 35 by 2 square. There are 10 equal sectors, so I divide this by 10. So area of each sector. So area of a sector is given by pi r square divided by 10, which gives us 385 by 4 millimeter square. 10th one. An umbrella has 8 ribs equally spaced. If the umbrella is flat and if the radius is 45 centimeters, find the area between the 2 ribs. So we assume that the umbrella is made into a flat circle. The radius is 45 centimeters. It is divided into 8 equal areas. So we have 8 equal areas. So these are the 2 ribs. So we need to find the area between the 2 ribs. So since there are 8 equal areas, find the area of the circle divided by 8. So area of the circle is pi into r square, 45 square, and area of each sector. So area of each sector is the area of the circle divided by 8. So that gives us 795.5 centimeter square. Next, a car has two wipers, each blade is 25 centimeters. So you have a car wiper, each blade is 25 centimeters and it sweeps an angle of 115. So this sweeps an angle of 115. This also sweeps an angle of 115. So 25 centimeters each. So we can find the area of this sector here. So area of one sector is the angle 115 divided by 360 into pi into r is 25 square into 2. So this entire thing into 2, since we have two car wipers. So we get the area as 158,125 divided by 126 centimeters square, or this is equal to 1254.96 centimeters square. So this is a simple problem. Problem 12. To warn the ships of underwater rock, there is a red light which forms an angle 80 degrees and which beams the light up to a distance of 16.5 kilometers. So we need to find this area. So now this forms the radius 16.5 kilometers and the angle is 80. So to find the angle of this entire sector, we have the area of the entire sector is 80 by 360 into pi r square, which is 16.5 the whole square. So we get the total area is 189.97 kilometer square. 13. There is a round table with 6 equal designs. So there are 6 equal designs and the radius of this circle is 28 centimeters. The radius of this round table is 28 centimeters and the cost of design is 0.35 per centimeter square. Right, so now we need to find what is the total cost to make this design. So if I consider the area of one sector, so we have AOB, the angle is 60 degrees and this is 28 centimeters, 28 centimeters. This is 60, so all of them are 60, so this forms an equilateral triangle. So now let us try to find the area of the entire circle. The area of the entire circle is pi r square, 28 the whole square. From this, the area of one sector. So the area of one sector is, the angle is 60 divided by 360 into pi r square. So this is the area of one sector, which is 410.66 centimeters square. So now to find this area, the area of the design, I need to subtract the area of the sector, one sector, from the area of the triangle. So area of triangle OAB is root 3 by 4 into r square, which is 28 square. So this gives us 333.2 centimeters square. So the area of the design here, so one of them is 410.66 minus 333.2, which is equal to 77.46 centimeters square. So this is the area of one design segment. So now the area of 6 design segments is 77.46 into 6. So that gives us 464.76 centimeters square. The cost of making the design per centimeter square is 0.35, right? So this is 0.35. So the cost of making the design for this entire area is the total area into 0.35. So the cost is 0.35 into 464.76. So that gives us rupees 162.66. So the entire cost to make this design is rupees 162.66. Problem 14 is a multiple choice. The area of the sector of angle P degrees of a circle of radius r is. So we need to find the area of the sector. The area of the sector is given by the angle is P divided by 360 degrees into the area of the circle, which is pi r square, where r happens to be the radius of the circle. So let's see the four options. We have P by 180, 2 pi r. B is P by 180, pi r square. C is P by 360, 2 pi r. And D is P by 720 into 2 pi r square. Now if we observe, I have pi r square here, but here we have P by 180 here, so these two options are not correct. And similarly there is r, so this option is also not correct. But here I have P by 720 into 2 pi r square. So if I multiply this by 2 and divide by 2, I get 2 pi r square divided by 720 into P. So the right answer is D. So with this we have completed all the problems given in the second exercise. I hope you have found all the problems informative and useful. Make sure that you do like, share and subscribe and press the bell icon to get notifications of further uploads. And thanks for watching.